Hello everyone, this is Ben Ryder from the Academy of Gaming Film and Animation, and finally what we're going to look at is how to get our custom characters into Unreal Engine. That is a skeletal mesh with animations and how to blend those all together and have them as a working character inside of Unreal Engine. The same process that works for Unreal Engine 4 works for Unreal Engine 5, so let's get started. So the first one we're going to actually bring in here is going to be this idle animation. Now we could bring in a static animation, but we're just going to skip ahead to a few steps. So this is our dwarf animation here. We press play and there they are breathing up and down, and then we have our other ones in here. So I'm going to left click, and so first of all I'm going to set up a folder in here, and I'm going to call this one characters. And then we're going to just drag and drop that object in there. It's going to be similar to the way that we did the chest, but we're going to have a few differences later on. So we're going to import the skeletal mesh, import the mesh, have the scale of 20, and we're going to import the animations for this one, because in this case we do actually have an idle animation that we want there. So we'll go import. Once again, I am fairly certain that the roughness will probably not have come through. What do you know? Unreal is nothing if not consistent. So we go here to our source images, and there's our roughness and our metallic. The metallic came through, just not the roughness. So we'll fix that first. We'll change it from pasted. That's never a good name. So there's our roughness. We plug that in there, and that can go in there. And that's actually gone into spec. I'm going to plug that into metallic. There we go. That'll give us that nice little roughness and shine to the hair there. Going to save. You can play around with these values to try and get them a little bit less intense by multiplying them by different values, but just for now we just wanted to show you and make sure they are in there. Good, excellent. All right then. So yeah, we'll change this to dwarf material. Before we looked at the physics asset and we talked a little bit about the idea of having a ragdoll, we might look at that if time permits, but just for now I just wanted to get the character working, because we're not going to have them in the level. When there's a character there, they'll have their own capsule there as a physics object, so that'll work just fine. So here's our animation, seems to be working just fine. So now let's talk about how we can get these animations to talk to an actual character, but we'll set up the character first. And we'll go from there. So we will have a playable, movable character, and then we'll start talking about how we make that character animate while they're moving. So I'm going to put in a new folder in here called anims, and for now we'll just put that there. And let's set up our character blueprint. So we've got a blueprint. So we're not going to go to actor, we're not going to go to pawn, we're going to finally go to character. And this is going to inherit from a lot of things, but that means that when we go up and try and use our other assets, because we actually had them all inherit from that character one, we won't have to reprogram them, which will be really exciting. So bp underscore dwarf, there it is. So what we're going to do now is go over here to mesh, and we're going to, so as you can see from a skeletal thing, and this will be important for later on when we start talking about class structures, it already has a few things that it inherits as a default component. So its default component is it has a capsule that is going to be taking care of all those physics collisions for us. It already has an arrow that points out to its front and its forward facing direction, and it already has a skeletal mesh in there, as well as this character movement, which has already scripted up all of our things from walk speed to jump height to all those different things there. So it's already giving us a lot to work with to begin with. So if we go back here to mesh, the first thing we're going to do is get the dwarf in there. So there they are. We're going to drag them down to the bottom there, press F on the keyboard, and we're going to then rotate them around so they're facing in the direction that we want. Go compile, and let's see how that character looks in the level. There they are. Yep, sizing's all looking really good. So that's excellent. All right then, so what we want to do now is we now want to put in a camera. We need to be able to see the actual character itself, so when we possess it, it knows which camera to possess. Before we do that though, we're going to put in a spring arm. So a spring arm, especially for third person perspective, acts as a way of being able to set the camera away from the character and act as a bit of a camera boom arm. So we're going to put the camera on the end of this arm here. So I'm going to go add camera. And we're going to make sure that camera is facing the right way. I've never had that happen before, but there you go, first for everything. Yeah, definitely haven't had that happen. That's very odd. So now when we rotate the arm, the angle, the camera will follow, and that's exactly what we want. We don't want to rotate the camera, we want to leave the camera well enough alone. So let's just set this up so that we can actually rotate our camera around our character. So we're going to go here to event graph. So this event graph, just like it was with the static mesh with the sword and the chest, is the way that our player can interact with this object. But we've already got a few things in here. And one of the events we're going to cast has already been written in there. It's going to be called look up. So look up is an axis event. That means when I move my mouse up and down, it's going to trigger an event. So that's the one we want to use just for now. This is going to be the value of either being positive for up and minus for down. So we're then going to push that into the pitch. So if you've done any sort of flight sims in the past or played any sort of flying ones, you'll be familiar with how these sort of work and everything. If you're not, the way I always sort of start up with it for Unreal is always look up to the pitcher. So as your batsman, you always look down, then you look up at the pitcher before they throw the ball at you. So that's just the way I remember it. But if you're a flight sim person, you'll know and understand that terminology a little bit better than most. The other one we want to look at is turn. And it's going to be turn, right and left, mouse, input, access events, and then we're going to go into yaw, as in Y-A-W. Again, don't turn your back on me as the way I remember it, because I'm not a flight sim person, but if you are, then you'll already know that yaw is how the plane turns. So that's just there. And now we're just going to have to change a few things by default in here. So I'm going to first uncheck this box in here. So by checking these different things, they bring up different details here. So under there, I'm going to say I'm not going to use the pawn rotation. So that just means that the character is not going to be locked to wherever I move my mouse. They're going to stay stationary. I'm then going to go to my spring arm, and I'm going to use pawn rotation and check that. I'm going to finally go down here to character movement, and I'm going to type in orient rotation to movement. So that means that when it basically allows me that when I move my mouse around, I can see my character, and then when I press forward or backwards later on, it'll change the character's orientation to match where I'm looking. So I can look in the direction I want my character to go. But just for now, let's check to make sure this works. Let's bring that into the level. And the other thing we want to do just before we press play on this level is we want to set up this actor to be the one that is possessed at the very start of the game. So here we have pawn. It says here player possesses disabled. We're going to change that to player 0, which is the first player that spawns. We're going to change AI controller class to player controller. Compile. So now when we press play on this level, instead of going on the mannequin, it's actually going to go on this dwarf. And as you can see, as I move my mouse around, you can see our character. Nothing else happens at the moment. It's not taking any other inputs, but it's working around just nicely like that. So now let's talk about our other inputs, moving it forwards and backwards. So if we go here, we're now going to go to move forward and backwards. This is another axis event for your W and your S. So X values here, positive for W, S for -1 for backwards. But we need to first say, well, what is forward? If we just left this the same way it was, it would just take the world initiative for that. So for example, if I go here, add movement, which is a function here that basically moves in here, I'd have to determine which way is forward first. And if our forward way was always the same direction, then that'd be great, but we want the forward direction to be wherever the arm socket is pointing. So if it's pointing forward, absolutely. If it's pointing somewhere different though, say to the left or the right, then we want to change that as well. So we basically want to grab the spring arm by left clicking and dragging into here, and then from there we want to get its socket rotation, and then from there we want to get its forward vector. So a forward vector is, in this case, this is the character's forward vector, but anytime an object moves or rotates, the forward vector changes. So we want to actually make it so that this gets the socket rotation and then gets its forward vector. And then that is going to determine the world direction of what we consider to be forward and backwards. We can then plug that into there. And now if we go back into our game and we press play, W and S will move backwards. So you can see the character orients to the direction they're facing, they rotate around. But let's say I now look in this direction, it'll consider that to be forward. So here we go, we've got our character ice skating around quite nicely. But this isn't, really what we want. We want those animations to play as we move. So basically we want it to detect the velocity of this character, and when the velocity is above 0 or a certain speed, we want it to animate in that walk cycle and run cycle. So to do that, we first need to set up our animation blueprints. So we have our animations here for an idle animation, but now let's bring in our other animations. So we're going to go here, walk animation, bring that in. I'm going to uncheck import mesh and go here to dwarf idle and make sure that it's still 20, go import. And there it is, there's my walk cycle. And then I'm going to bring in my run cycle as well. And uncheck import mesh, dwarf, import, and there's my run cycle. Now, something to consider. How do I make it? See, with our skeletal mesh, we just had it that it plays an animation. It was very simple, but we want this to blend from idle to walk to run. So we kind of want these overlapping on each other and to change as the character's velocity changes. So to do that, we're going to use what's known as a blend space. A blend space takes all of the animations that are associated with a specific skeleton, which is why it was important to make sure these all use the same skeleton. And then it looks at how it can make it so that it blends between these two, given a certain value. So we're going to go here and right click to animation and go, in this case, I'm just going to use blend space one dimensional, just to keep things simple. Later on you can use more complex blend spaces, but for now we just want to go with something simple. So I'm going to call this one BS_dwarf. And we're going to double click on it. And because we've selected that particular skeleton, it already knows which skeleton to have, and it already knows all of the animations that are associated with it. So I'm going to just bring this idle animation in first, and then a walk, and then a run. Now in this is a little bit different than 4. In 4 you could just left click and drag wherever you want to and see how these two blended, but here you've got to actually hold down the control key and then it will actually do those sorts of things. So control and then left click and drag. So this is a graph. Graph has an X and a Y axis. In this case, because we went with one dimensional, it only has an X axis, which in this case is the horizontal axis. And I'm going to call that one move speed, which will become apparent later. Now, when we're actually looking at the character's move speed, their walk speed, for example, the max number I've noticed for character movement seems to be 600. So what we're going to do then is make sure that when we go into our animations here, that we're using those same amounts of units. So maximum here, 600. So that I can pull this run all the way to the end and this walk cycle somewhere to about, say, here. And then save. And that just means that later on when I'm running at that speed, that's the speed it actually moves at. So that's all done. We've got that to there. I can select snap to grid and that will keep those values locked into 150 and 600. So now we can set up a blueprint that will detect whether the capsule is moving at that velocity. So we now need an animation blueprint. Now this is where things can get a little bit confusing and where we lose a lot of people, but trust me, after you've done it a few times, it will all make sense. It starts off simple enough. We've just got to select our skeleton. So we go create. I'm going to call this one AB_dwarf. And now things start to get a little bit confusing. So let's just walk through it slowly and it will begin to make more sense. So first of all, we have our character here. At the moment, nothing is happening because nothing is being posted into the output pose, its final pose, if you will. That's because it needs to look at what state the character is in before it decides what animation it needs to play. if it's in an idle state, should play an idle animation. If it's in a wounded state, it might play a completely different idle animation where it's limping a little bit. If it's in a power-up state, it might be moving in a different state altogether. So it is confusing, but it's all because characters are very complex, and so we need to have something that can capture that complexity. For now, we're going to try and keep things simple by just having one state machine. And then over here on our event graph, we're going to set it up to say when this capsule is moving at a certain velocity, plug that velocity value into the move speed, and then have that move speed change the animation state. So we'll start doing things, and hopefully things will make a little bit more sense. So we should see both of these things down here. If you don't, you can just open the mark up here. So for example, if animation graph is not there, you can just double click on it and it'll appear back here, and same for the event graph. So if either of those two things are missing, that's how you get those back in there. We're going to start on the animation graph. I'm going to right click in here and type in new state machine. And then we're going to left click and drag this into here and go compile. Still nothing moving, but that's fine. That's generally because it says there's nothing connected to the state. It goes into entry and it leaves into nothing. Now in the top right hand corner, conveniently enough, we have all the animations we could have. Now we could set up an animation tree here with, a true or false to see if it's above a certain level, move into the other one, but we've already kind of done that with our blend space. So if I left click and drag this here into the level like so, I can then left click and drag this to here to the outside rim, and then click compile, and automatically it'll be like, oh, you want this to be an idle. That makes sense. If we double click on this, we can see our animation blueprint that we just created, and there's move speed, which is the exact same value we called it here. In fact, if I change this to say a capital M and go save, you'll see it changes here as well. In fact, if I change this default value to 150 and go compile, you'll see they start to walk even. So really what we need is something that's going to update this to say, make this, when this value changes here, move up and down this blend space. So I'm going to right click on here and go promote to variable, because it's going to create a variable inside this blueprint here. Now I know we already had a variable inside of our blend space, and it seems weird that we're creating another one here, but this is the animation blueprint and that was the blend space. So we kind of need to recreate a way of capturing that value there as a float. So we've got this all set up though. This part of the state machine now is pretty much done. We don't have to do anything else to it, which is good. We can now go into our event graph and start setting this all up. So a couple of things we have here. This is the event blueprint update animation. This is really good because it updates all the time without having to use an event tick, which is really handy. It takes up less memory and it's really good. But again, as we start going through this, you'll start to notice that we want to recycle assets as much as possible because of this. We don't want too many of these running at a time. So if you can recycle them and have them apply to all different characters, then that's always good. But this here is our pawn owner. That is our character here. So basically from here, we want to get the velocity. And that is basically going to get the velocity of this thing when it's moving. So when we press W or S, it's going to check to see what speed our capsule is moving at, and then apply that into the move speed. So here we can go to set move speed. But as we go and try and plug this into here, we notice there's a problem. This is a vector and this is a float. This is going out in all different directions and this is going out in one. So we've got to go in here and type in length. It's going to give us the vector length, which is basically going to convert no matter which direction the velocity is in, it's still going to assume that and just translate it just to one number that can go into this float here. Now, there is one little thing I'm going to put in here called isValid. And this is just going to check to make sure this character is actually valid. It's a bit of a fail-safe there. You don't want this trying to apply move speed to something that isn't a character, basically, and doesn't have any of these things put into it. So it's just a check there to make sure that is all good. But now we should be able to play our animation. So if we go back to our blueprint, and that is our character blueprint here, you'll notice the character's still not moving. And that's because when we go to our skeletal mesh, we go over to the right here to values, we'll notice it's asking to use an animation blueprint, but there's no animation blueprint there. But if we drop click down here, we can see animation blueprint dwarf, and when we click it, lo and behold, he starts moving. So we can go compile, and now when we go back into the level and press play, you can see the animation of the idle animation is playing, and then as soon as we start moving, the character starts running. Now we might want to change the speed here because they can launch straight into a run, which we may not want. So we're going to go back here to dwarf, movement, and change their max movement walk for now to 150. Go compile, go back in, and there we go. Got a nice jolly little walk there for our dwarf. And as we come up to our chest here and press E, it still actually recognizes the fact that this is a character and allows us to have all the interactions. And this is the first introduction to why we want to use a class structure with our object-oriented programming to make sure that we can actually inherit those things. Later we'll then start looking at, well, how can we make it so that all of our weapons are the same? So bringing in multiple weapons, bringing in multiple chests, making it so it spawns in random weapons, and then applying that so the character can hold that weapon and have different values to that. But that's all things we will look at later. For now, the main thing about creating and importing 3D assets has been completed, which is going from our static mesh to our skeletal mesh animation all the way through to our character. Now there's one more thing I will add into this character though, and that is their move right. We kind of sped ahead here. We've got our move forward, but when we press A and D, the character doesn't strafe or move to the left or right, so we've got to fix that. So we're going to go here, move right and left, and I'm actually going to copy that because I want to get the right vector. So we have a forward vector and we have a right vector. And we're going to use that, plug that into there, plug that into there, and make sure our axis value goes into there, compile, and now when we press play and I press A and D, our character moves to the left and right, which is good. Cool, so that's all I really wanted to look at in this video series, is going through those three different ways and three different assets basically, and looking at how they get imported into the Unreal Engine, and just testing to make sure that they all still carry over to Unreal Engine 5, which as you can see they do. So you now have everything you need really to get through Engage, Stage 1 and Stage 2. Obviously for Stage 2 for your main character, you're going to need to add a little bit more to it as part of your resource study. That could be adding in cloth physics for the hair, or maybe putting on armor that you can add and then take off, or adding in a sword or inventory system, but that is up to you as to what extra you will add and what is important to your character. So with that, I will leave you to that, and I look forward to seeing the amazing and wonderful creations that you will bring to your game assets.